Good morning, students. In today's class we are going to discuss about the next part of the mole concept, that is mole concept 7. This is the last part of the mole concept, mole and its applications, right? With this we will come to an end of the mole concept, but in this today's class I would like to discuss about the next method of expressing the concentration of solution, that is mole fraction, and how it is related to the remaining methods of expressing the concentration, molarity, molality, and related problems we are going to discuss in today's class. This mole fraction is denoted by chi. This is a symbol for the mole fraction, chi I. Okay. What is mole fraction? Let us see the definition of mole fraction there. As the name indicates, it is a fraction. It is a ratio between what? Between the number of moles of one component and total number of moles present in the solution. So mole fraction can be defined as ratio between number of moles of one component in the sense either it is the solute or solvent, of one component and total number of moles present in the solution. Is called as its mole fraction. Right. This is the definition of the mole fraction there. Here I would like to tell you a very important point here, that is it has no units. Because it is a mole fraction, because it is a fraction. And one more important point here, that it has no units. Suppose if you take up one simple solution, okay, I am taking up a binary solution. If we take a binary solution, okay, I am taking up a binary solution, which is containing both solute and solvent. Let this solute as A and the solvent you take as the B. Okay. Now NA is representing what? It is representing the number of moles of solute. NB, it is representing what? It is representing the number of moles of solvent. There. Okay. Now if you want to find out the mole fraction of solute, which can also be written as a mole fraction of A, how do I write? Number of moles of solute, that is Na, by total number of moles, Na plus Nb, I am taking up here. Okay. Now similarly, if you want to find out the mole fraction of this solvent, then what we will do? Chi B, this is equal to NB, this is the number of moles of solvent. Total number of moles, same again, that is Na plus NB there. Now if it is a binary solution and only two components are there, this is what we are getting there. Suppose if you take up the sum of the mole fractions in that solution, chi A plus chi B is equal to what we will get? Na by, that is Na plus Nb. And what is the mole fraction of B? The mole fraction of B is Nb by Na plus Nb we are getting. Now if you take up the LCM, here number of moles are Na plus Nb, and here you are getting Nb plus Na, and both of them gets cancelled. Here what we are getting is 1. So therefore one statement I can give you here, that not only for this solution, for any solution, the sum of the mole fractions, sum of the mole fractions of all the components in a solution is always equal to 1. It is always equal to 1. So this is applicable for any solution, whatever number of components it contains there. Okay. Now the one more expression of this mole fraction we can write down, that imagine chi A can also be written as, here I have already written that Na by Na plus Nb. Suppose if number of moles are not given, only weight is given, that Wa by Ma, that weight of the solute divided by its molecular weight. Similarly Wa by Ma plus, here it is Wb by Mb we are going to get that. Okay. This is the expression for the mole fraction of A there. Similarly, directly we can write down that mole fraction of B can be written in terms of the masses. That is, directly I am writing that it is Nb by Na plus Nb. I can also write it as the Wb by Mb by Wb by Mb plus Wa by Ma. Right. This is in terms of the masses. Now we shall see that how we can do simple problems by using this mole fraction there. Suppose simple problem is given like this. Problem number 1 in this mole fraction concept there. A gaseous mixture contains 2.2 grams of carbon dioxide, 1.6 grams of methane, and 3.2 grams of oxygen. Find the mole fractions of each component. Let us see. This is a problem. Okay. Now the solution of this problem is that the number of moles are not given here directly, weights are given there. So let us find out that the number of moles of carbon dioxide is equal to, what is the weight given? 2.2. What is the molecular weight of carbon dioxide? That is 44. This is giving you 1 by 20. 1 by 20 is equal to 0.05. Similarly, number of moles of methane is equal to, what you'll get here, the weight is given 1.6 and molecular weight is 16. This is 1 by 10. 1 by 10 is equal to 0.1. Then number of moles of oxygen is equal to 3.2 by 32. This is also giving you 1 by 10. It is equal to 0.1. Now if you find out the mole fraction of carbon dioxide is equal to 0.05 by total number of moles. What is the total number of moles here? The total is getting that 0.25 we are getting. This is 0.25. This is equal to how much you are going to get then? That 5 by, this is 5 by 25. 5 by 25 is nothing but 1 by 5. 1 by 5 is nothing but 0.2. This is a mole fraction of carbon dioxide. Similarly, if you want to find out the mole fraction of the methane, okay, then how many number of moles of methane are there? That is 0.1. I am taking up here 0.1 and here it is 0.25. This will be equal to 0.1, 1 by 2.5. 1 by 2.5 you are getting. Or it is 10 by 25. 10 by 25 is nothing but equal to 0.4. Okay. The next one is the number of, that is oxygen. Now that is 0.1. Total number of moles are 0.25. Same thing as the methane there. Here also you are going to get 0.4. You can see that 0.2, 0.4 and 0.4 again giving rise to the total 1. That sum of the mole fractions always equal to 1 there. Okay. Now we will discuss that the relationship between mole fraction and other methods of expressing concentration. Suppose with weight percentage, what is the relationship? Let us see. With weight percentage, how the relation can be given. Suppose X% of solution, W by W, is given and mole fraction of that solution, is equal to what? How do you get the mole fraction of the solution there? Let us see. Suppose if X% is given there, X% of solute is present. Okay. Now, what is the weight of solute there in this? The weight of solute will be X grams, because the X percentage indicates X grams present in 100 grams of the solution there. Okay. X grams in 100 grams. This is the meaning of X percentage. Now it will contain what weight of solute? The weight of what weight of solvent it will have, that is 100 minus, this is equal to 100 minus X grams. Okay. Now we have to find out what is the number of moles of solute. Number of moles of solute is equal to X grams of the solute and solute molecular weight. Similarly, if you want to find out number of moles of the solvent there, that is equal to 100 minus X by molecular weight of the solvent there. Okay. Now if you want to find out mole fraction of solute is equal to number of solute, that is x by m solute, then total number of moles x by m solute plus 100 minus x by m solvent. This is a formula to get the mole fraction of solute there. Similarly, if you want to get the mole fraction of solvent, the formula is 100 minus x by molecular weight of solvent by x by molecular weight of solute plus x by molecular weight of solvent. Okay, this is how we can get the mole fraction of solute and solvent if x percentage or weight percentage of the solution is given there. Let us see one problem here, that problem number 2. Let us discuss here that find the mole fraction of mole fraction of 20% W by W of sodium hydroxide solution, suppose. Then how to get this number of moles of the solute there? Let us see that 20% W by W there. But meaning of this one is that 20% W by W means, the meaning of this one is, what does it indicate? It indicates that 20 grams of sodium hydroxide is present in 100 grams of solution there. In 100 grams of solution, this is the meaning of this one. Now number of moles of sodium hydroxide is equal to 20 by 40. This is equal to 0.5. Then number of moles of water is equal to, or whatever may be that solvent of aqueous solution, it should be aqueous solution there. Okay, then it should be 80 by 18 there. So whatever value you will get, we will take up here there. Then mole fraction of sodium hydroxide is equal to, how much you will get? 0.5 by, this is equal to 18 by 80 by 18, right? This is equal to, what I am getting is 80 by 18 plus I can take it as 1 by 2. Then on simplification we will get here that this is 18, 80 plus 9, this is 1.2, 1 by 2 I will write again, this is as a 1 by 2, 1 by 2. Then what I will get here is 1 by 2. This is equal to 1 by 2 into 18 by, this is 89. This is equal to 9 by 89 is the mole fraction of sodium hydroxide. This is the answer of this problem there. Okay. Now we shall discuss about the relationship between this mole fraction and molality, which we have already discussed there. That imagine that a solution is given to us, okay, and molality of this solution is xm molal solution is given there. And what is the mole fraction of solute. Now imagine that it is an aqueous solution there. It is an aqueous solution. Okay. Now xm means what? The meaning of x molal solution is x moles are present in x moles are present in 1000 grams of solvent. 1000 grams of solvent. Okay. Now already we got the number of moles of the solute here. How to get the number of moles of solvent there? Okay. So number of moles of solute, that is nothing but is equal to x. Now number of moles of solvent we want. Number of moles of solvent. This is equal to weight of the solvent is 1000 here, and gram molecular weight of the solvent we should take, that is nothing but aqueous solution. Since it is an aqueous solution, I can take up here that 18. Now this will give you 1000 by 18 is nothing but 55.55. Okay. Now if you want to get the mole fraction of solute, then I can take up here that x, the number of moles of the solute. Number of moles of solute is again x there. This is number of moles. 55.5 is the number of moles of the solvent. Now in place of this, I can write down, in place of x, I can directly write down here that we can directly write down here that x we have taken as the molality, that is nothing but number of moles there. So I can take up here molality plus 55.5 there. This is applicable for all aqueous solutions there. Suppose aqueous solution is not present, some other solution is present, solvent is different, then for other solutions what I should do is that for other solutions this 55.5 will be changed here because it is the number of moles of water here. Then what happens there? That mole fraction of solute is equal to m by m plus 1000 by molecular weight of the solvent given, right? This will give you mole fraction from the molality. Suppose, let us discuss one problem based on this concept here. Problem number 3 in this class. That is right. Now the problem is like this. Find the mole fraction of calcium carbonate in mole fraction of calcium carbonate instead of calcium carbonate, let us take up here that find the mole fraction of, let it be, find the mole fraction of solute, in 2 molar aqueous solution of sulfuric acid. This is the problem. Now the solution of this problem here is that the number of moles of sulfuric acid, I can directly take it as the 2, because 2 moles are present there. Now weight of solute, how much weight of solute is present there? Where are these 2 moles are present? 2 moles are present in 1 liter there. The weight of the solute is equal to 2 into 98. That is nothing but 196 grams we are getting here. This has to be subtracted from the 196 grams I have got here. That so this is molal solution. No, sorry, it is not 1 liter. It is for 1 kilogram of the solvent there. Okay. Now let us discuss here that what is the weight of solvent there. The weight of solvent is equal to 1000 minus 196. This is giving you that 804 like this, 804 grams we are getting. 1000 minus 196 there. Now if you want to find out the mole fraction of the solute, that is nothing but sodium hydroxide there, that is sodium hydroxide, then we are going to get here that weight of this number of moles already we know, 2 by 2 plus 804 by 18. So this on simplification you will get the, this on LCM we will get the 18, then 36 plus 804, this is 2, then equal to 2 by 1 into 18 by 36 plus this one, how much you are getting there? 840 I am getting here. This is 36 by 840, 36 by 840 there. Now 4 9 ja 4 201. So this is a mole fraction of the sodium hydroxide there in that particular solution. Right. Now here is asking the mole fraction of the sulfuric acid. I'm sorry, it is not the sodium hydroxide there. It is the sulfuric acid. Now we will discuss that how this mole fraction can be related to the molarity. Relation with molarity. Relation with molarity. Relation with molarity. Whenever molarity is given and you want to convert that into molality and mole fraction, we need the density there, right? Suppose imagine that X molar solution is given. X molar solution is given whose density is equal to D grams per cc, suppose. Now it is an aqueous solution. The nature of the solution is also required here. It is an aqueous solution. Now what is the mole fraction of the solute is asking that. Okay. The mole fraction of solute we can find out here. Mole fraction of solute, how we can find out, let us see. Okay. Now to get the mole fraction of solute, what is the requirement first that you have to look into this? That is, you need the number of moles of solute there which is already with you, and the number of moles of solvent also you need here that. Okay. Here number of moles of solute is nothing but X I can take, because X molar solution is nothing but X moles present in 1 liter of solution there. 1 liter of solution. X moles are present in 1 liter of solution there. Now you can take up here that this is X, already we know this is X plus, but number of moles of solvent. Now the problem is how to get this one, number of moles of solvent. Getting this number of moles of solvent is a process here. Otherwise number of moles of solute is very easy here. Okay, to get the number of moles of solvent, we need to know the weight of the solvent. To get the weight of the solvent, we need to know the weight of the solution there. Now, the weight of solute is equal to, what is the weight of solute here? That is X into gram molecular weight of solute I should take. This is the weight of the solute. Then, what of the weight of the solution? I can get the weight of the solution by using the density parameter there. That is, density is nothing but d grams per cc there. For 1000, how much it is? 1000 into d grams. Okay. Now I want weight of solvent. Weight of solvent is equal to this minus this, 1000 d minus x into molecular weight of solute. Now we got the weight of the solvent there. Okay. Now I want number of moles of solvent. How I get that? Number of moles of solvent is equal to 1000 d minus x into m solute by gram molecular weight of solvent. Gram molecular weight of solvent. The same thing I will substitute here. What I will get, let us see. That is, mole fraction of solute is equal to x by x plus 1000 d minus x into gram molecular weight of solute. This is the gram molecular weight of the solute there. Okay. That is m solute I am writing. Then this is divided by gram molecular weight of solvent. Now in place of x, now I can write that x solute is equal to, that is simply nothing but molarity. Molarity by molarity plus, and this total term is 1000 d minus x into molecular weight of solute by molecular weight of solvent. From this we can get the mole fraction of the solute from the molarity if density is provided to us and we know the nature of the solute. Let us do one problem based on this concept here, that is, the problem is like this. That is problem number 4. Find the mole fraction of 2 molar solution of which solution? That is also required here. 2 molar aqueous solution of sulfuric acid whose density is 1.2 grams per cc, or specific gravity of the solution is 1.2 grams per cc there. Now directly also you can substitute whatever manner we have derived this problem here, that what is the molarity is given to us, that is 2. The density is equal to 1.2 grams per cc here. Now aqueous solution is telling that, so we can get the mole fraction of H2SO4, that is equal to 2 by 2 plus then 1000 into 1.2 minus 2 into, that is sulfuric acid is 98 by 18 is the molecular weight of the solvent there. Upon simplification, what you will get is that 2 by 2 plus this is 18, this is 100 into 12, 1200 minus 16, 108. Okay, then it is equal to 2 by 2 plus 198. If you subtract from this 200, you will get 1002 by 18. Then on simplifying this one, you will get here that 1836 plus 1002 by 2. Now this is giving you that 2 by 1 into 18 by, this is 1038 1038 there. Then we will be getting that 36 by 1038. So this is the fraction of the particular solution. Okay, now I am giving you some problems. Try to solve these problems based on the discussion we already done in the mole concept there. Mole concept problems, and I am also providing one assignment with this, but these problems try to solve there. The problems are like this. First problem is mole fraction of iodine. Mole fraction of iodine in C6H6 is 0.2. Calculate molality of iodine in C6H6. Number 2, the density of 3 molar solution of Na2S2O3 is 1.25 grams per liter. Then calculate percentage weight of Na2S2O3, then mole fraction of Na2O3, which is nothing but hypo, then molalities of Na plus and S2O3 minus 2 ions. Okay, in the next class we will discuss other topic and work hard and continue work hard, and definitely you will succeed. Thank you. And if you want to succeed, that you need to do many problems there, and you have to do different types of problems, and then only you will get the clear picture of this mole concept there. So take down few more problems here. That is a third problem I am giving you, problem number 3. Problem 3, 6.90 molar solution of KOH in water has 30% by weight, 30% by weight of KOH. Calculate density of KOH. Then fourth problem, find the molality of H2SO4 solution, H2SO4 solution whose specific gravity, whose specific gravity, whose specific gravity is 1.98 grams per milliliters and 90% by volume, 90% by volume H2SO4. Next one, calculate molality of 1 liter solution, 1 liter solution of 93% H2SO4, 93% H2SO4 by volume. The density of solution is 0.84 grams per milliliters. Okay.